Myself, Kirtan M. Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari, Electrical Engineering Department. Subject name is Testing and Commissioning of Electrical Equipments. 4th year, 8th semester, and chapter is Safety Management. Now, syllabus content. First is factor affecting the earth resistance. Second one is methods of measuring the earth resistance. Third one is equipment earthing and system grounding. Fourth one is earthing procedure, building installation, domestic appliances and industrial premises. And fifth one is earthing of substation, generating station and overhead line. Now, first is factor affecting the earth resistance. First is soil resistivity, soil conditions, moisture, dissolved salts, climate conditions, physical compositions, locations of earthquake, effect of grain size, effect of current magnitude and area available. Main important factor is soil resistivity, soil conditions and moistures. In soil resistivity, it is the resistance of soil to the passage of electrical current. The earth resistance value, like ohmic value of an earth pit, depends upon the soil resistivity. It is the resistance of the soil to the passage of electrical current. It varies from soil to soil. It depends on the physical compositions of the soil, moisture, dissolved salts, grain size and distributions. Moisture's content, dissolved salts, grain size and its distribution, seasonal variations, current magnitude. Next is soil conditions. Different soil conditions give different soil resistivity. Most of the soils are very poor conductors of electricity when they are completely dry. Soil resistivity is measured in ohm meters or ohm centimeters. Soil plays a significant role in determining the performance of electrode. Soil with low resistivity is highly corrosive. If soil is dry, then soil resistive value will be very high. If soil resistivity is high, earth resistance of electrode will also be high. Now moisture. Moisture has a great influence on resistivity value of soil. The resistivity of a soil can be determined by the quality of water held by the soil and resistivity of the water itself. Conductivity of water held by the soil and resistivity of the water itself. Conductance of electricity in soil is through water. The resistance drops quickly to a more or less steady minimum value of about 15% of the moisture, and the further increase of moisture level in soil will have little effect on soil resistivity. In many locations, water level goes down in dry weather conditions. Therefore, it is essential to pour water in and around the earth pit to maintain moisture in dry weather conditions. Moisture significantly influences soil resistivity. Okay. So these are the very different points of factor affecting. It is also important for the earth resistance. Okay, these are the main three topics. Is now methods of measuring the earth resistance. First of all, what is earth resistance? Earth resistance of gathering systems is the resistance between the earthing electrode or mass and the earth. It is in ohms. With very good earthing mat, earth resistance is below about 1 ohm when ground is wet and irrigated. Here the value of ohm or earth resistance is first method is measurement of earth resistance measurement methods. This is a well-known and widely used method used universally for earth resistance measurement or earthing systems. Okay, this is the earth electrode. Okay, E, A, and P, and this is the earth level. Okay, this is the earth electrode or auxiliary electrodes. This is a voltmeter and ammeter, voltmeter in parallel and series in ammeter with the help of the battery. Okay, it is recommended for earthing electrodes and earthing systems of installations or substations up to 220 kV. In these methods, a standard earth resistance tester is used along with the current spike, a volt, and a voltage spike. The earth resistance tester is portable and has a built-in ohm meter and a hand-driven DC generator. The DC generator supplies current via the earth electrode, okay, and earth thing. It is recommended for earth electrodes and earthing systems. Okay. The earth resistance tester is portable and has a built-in ohm meter and hand-driven DC generator. The DC generator supplies the current via the earth electrode under test and the current spikes. The ohm meter measures ratio V by I, where V means voltage between electrode and the test voltage spike. Several readings of V by I equal to R are taken for different positions of the voltage spike. Okay. We can say also earth electrode auxiliary electrodes. Other name is voltage spike. Okay. The graph of distance x versus r is plotted. Any point on the flat portion of the x by r characteristic is considered to be the earth resistance R of the earth point under test. The resistance value can be between the fraction of ohm to a few hundred ohms depending upon the soil resistance and depth of electrode. Electrodes design. Electrode and earthing mass design is modified in case of hard rock. When the handle of the earth resistance meter is rotated, the current is driven through the earth. The voltage between potential spike and the earth point is given to the potential coil of the meter. Thus the current coil gets earth current, the potential coil gets voltage drop. The earth resistance meters reads resistance R equal to V by I. As the potential spike is moved at different distance from earth electrode, an almost constant value of earth resistance is obtained by the measurements. This constant value is called the earth resistance of the earth point. If earth resistance is high, what are the actions should be taken? Clean the surface of earth electrode, mix the soil in the earthing pit with charcoal, salt and soft soil mixed together. Pour sufficient water in the earthing pit. Second one is connect the earthing rod with the equipment by low resistance copper strip. And third is use more number of electrodes or larger mass. This is the basic methods of measurement of earth resistance. Second one is high current method of earth resistance measurement. This method has been recommended for larger earthing mass, EHV, AC and HVDC substations in which fault level are more than 30 kA. In high current method, the current spikes should be at least 3 meters long and should be located greater than 10 km away from the earth mat under test and in marshy wet land. The voltage spike should be greater than 5 km away from the earth mat under test. The voltage spike should be separated from current spike by greater than 500 meters in a marshy or wet place. Angle between voltage conductor and current conductor greater than 90 degree, preferably 180 degree Celsius. Current I is more than 10 ampere DC. Voltage is measured suitably by millivolt meter. V by I gives earth resistance under test. For large earth mats, earthly resistance is less than 0.5 ohms. So these are the different methods of earth resistance measurement. Now difference between equipment earthing and system grounding. Here it is a figure, symbolic figures. Here it is earthing and this is a ground. Okay. Now, what is difference between earthing and grounding? This method protects human beings from electric shocks, while grounding, this method protects the entire power system from malfunctioning. The earth wire used is green in color. The wire used for grounding is black in color. While in earthing is primarily used to avoid shocking the humans, while in grounding is primarily used to unbalancing when the electric system overloads. In earthing is located under the earth pit between the equipment body underground, while grounding it is located between the neutral of the equipments being used and the grounding. And next point is, what is neutral earthing and what are its advantages? Okay, connecting the neutral point of three-phase AC system to earth, earthing electrode or earthing mass by low resistance conductor is called neutral earthing system or system neutral earthing. The neutral points are available from the star connected generator, star connected transformer, star connected stator windings of motors. The earth is good conductor. Earthing mass is metallic fabricated mass of steel rods buried and placed horizontal in the ground. The neutral points to be earth are connected solidly to the earth by means of continuous conductor of low resistance, less than 0.1 ohm resistance. Neutral earthing is essential for star point at which voltage level of three-phase AC system. In voltage transformer, star point of VT secondary circuit. In current transformer, star point CT in secondary circuit. Now, difference between neutral earthing and equipment earthing. Okay, here it is also earth or ground versus neutral. Earth or ground in mains AC power electrical wiring system is conductor that provides low impedance part to the earth to prevent hazardous voltages from appearing on equipment and bring back the fault current. While in neutral is a circuit conductor that normally carries current back to the source and is connected to earth at a main electrical panel. In earth, ground is normal, ground is not neutral. In neutral can be grounded. The color of earth wire is green or green-yellow mixture, while in neutral, color of neutral wire is black. Equipment earthing refers to the earthing of non-current carrying parts such as motor body, switchgear, enclosure, transformer, tanks, condition, support structure, towers, poles, cables, sheath, body of portable equipment, earth terminals of surge arresters and earthing switches. Neutral earthing is different from equipment earthing. Neutral earthing refers to connecting to ground the neutral point of star connected winding. In underground systems during a single earth fault, anywhere in the systems, the voltage of two healthy phases with respect to ground rises to √3 times normal phase to ground voltage. Such sustained overvoltage is harmful to motor insulation. Hence, ungrounded neutral system is no more preferred to supply systems. All modern systems are with grounded neutral. Earth or grounded neutral system has following advantages. It's easy for earth fault protection. Its transient overvoltage are easily dispatched to earth. These include lighting and switching over voltages. Neutral earthing at each voltage level. The neutral of star connected three-phase winding of transformer can be earthed. The neutral generator can be earthed. If neutral point is not available, a separate star delta transformer is arranged. Star point can be earthed. Sometimes special earthing transformer having zigzag winding and neutral point is provided. A rule to be followed provided neutral earthing at every voltage level. Modern three-phase AC systems have gained universal acceptance due to the neutral earthing facility available. Neutral earthing is also called neutral grounding or system grounding. It is the following significant advantages. First advantages is the neutral point remains stable in underground systems. The neutral point plots the phase to earth voltage of three phases vary with the time. The measurement of wattmeter, energy meter are not stable without neutral earthing of secondary stars of three-phase CT and VT connections. Neutral earthing connections provides return point to earth fault return current and provides facility to simple earth fall protection. Earth fall relay in neutral CT can trip the circuit breaker. Earth fall can be easily sensed. Without neutral earthing, earth fall protections become particularly impossible. Next is arcing grounds due to repeated charging and discharging of the phase to ground capacitors through minor earth fault anywhere on the that voltage level are eliminated or minimized by neutral earthing at that voltage level. Next is voltage rise and insulation failure of other healthy equipment during earth fault, and the voltage level is prevented by neutral grounding. And next is insulation coordination get made very effective and economical. Without neutral earthing, equipment and system at each voltage level require next higher insulation level. Equipment earthing is the connecting the non-current carrying metallic parts of electrical machines, equipments and to the earth. The equipment earthing provides safety to personnel against severe shock from faulty electrical machines or equipment. Earth metallic part remains at near earth potential and therefore is the earthing provides safety. Touch potential and step potential are within specified limits. Earth fault protections of equipments become easy because of leakage currents flow through the earthing connections. Neutral point earthing is connections of current carrying conductor neutral to earth, but equipment earthing is connections of non-current carrying metal parts to the earth. Okay, so these are the difference between earth and neutral. Now, earthing procedure of building installation, domestic appliances and industrial premises. Here is a low voltage, high voltage zone and building services. Okay, these are the cable rigs, low voltage switch gear, LT switch gears, communication center, floor reinforcement. Okay, all are the connected with the help of system earthing. Okay, and these are the high voltage zone. This is the high voltage switch gear. Okay, base frame, generator bus, cable racks, pressure relief, door earthing, metal structure, floor reinforcement, transformer room. Okay, all are connected with the help of the earthing. Okay, so this is HV motors. In buildings and services, there are cable racks, lift guide rail, metal structure, heating pipes, insulation section, gas supply, water supply. Okay, these all are connected with the help of the earthing. Okay, so this is the most important. Now, in residential lighting control, okay, residential wiring for small connected loads below 1.5 kilowatt is with the single phase supply through the single phase energy meter, switch and single phase switch fuse combinations. After the main fuse, branch fuse as are provided for grading of fuses. For connected load of 2 kilowatt and above, 3 phase 4 wire supply is provided. The incomer switchboard has a 3-phase energy meter, a 3-phase master switch fuse unit and branch fuses or MCBs. Okay. With the 3-phase supply, the lighting and other loads in residential buildings are as a rule single-phase loads. However, they are connected such that the loads connected between the 3 phases and neutral are distributed in almost balanced way on 3 phases. Now, what is the earthing system for residential building or of small substations? It has only 1 or 2 earthing electrodes. Okay, The earthing electrode is in the form of metal plate or pipe or rod buried in the ground with charcoal mixed in the surrounding soil, and space should be kept moist to reduce the earth resistance. Small installation may have earth resistance up to about 2 ohm. Earth resistance of earthing system is the resistance between the earthing electrode mass and the earth. It is in ohms. With a very good earthing mat, earth resistance is below about 1 ohm when the ground is wet and trigger. Okay, so in buildings installation, domestic appliances and industrial premises, earthing is very important procedure. Equipment earthing. To ensure the body, structure, other non-current carrying parts are held at each potential and are safe to touch. Okay. Neutral earthing. To ensure that neutral points are held at earth potential and return path available to the neutral currents. Chassis earthing. To prevent electromagnetic noise or disturbance in measurement, control, protection, communication signals. Discharge earthing. Discharge earthing to provide discharge path to capacitive currents, earth return currents, and lightning and switching surges. Okay. Now, what is difference between touch potential and step potential? If a person standing on substation floor touches a faulty structure by raised fingers, the potential between his raised fingers and the feet is called touch potential. If fault current is flowing through the ground of the substation, a potential between two steps of person standing on the ground is called step potential. A person moving in the switch gear and touching an earth metallic structure should not get a shock. Hence, touch potential should be below 45 volt. Also, step potential should be below 45 volt so that a person walking on substation floor does not get shock due to high step potential. Okay. Now, protective measures against lightning strokes on overhead transmission lines and outer substations. Lightning strokes are electrically discharged from charged thunderclouds to the earth. The voltage are 200 kV peak and current. Typical lightning surges is represented by 1.2 microsecond to 50 microsecond voltage impulse wave, where 1.2 micro is wavefront and 50 microseconds is the half time of the wavetail. Okay, so these are the earthing substation of generating station, substations and overhead line. Okay, these are the substations. Okay, these are the overhead lines. Okay. These are the extrodynamic welding part connected to the. This is connected to the earth. Here this is the substations. This is the extrodynamic welding. This is a rock, the transformer, high voltage control. This is the control room. Okay. All are connected with the help of the earthing to earthing systems. The lightning strokes are intercepted by the overhead transmission line or towers and distribution lines, poles, outer substations, tall buildings, etc. The direct stroke produces voltage surge in the transmission line and distribution line that causes flashover and failures of line insulators and terminal substation equipment, generating station equipment, etc. Extensive damage, fires and destructions by heat, loss of life and properties are caused by lightning strokes. Porcelain insulator shatter, transformer fail, tower are destroyed, lines and damaged equipments get flashed over and damaged. Induced lightning surges are produced by passing charge cloud by induction's effect in the transmission distribution line. Induced lightning surges have less severity than direct strokes. However, they can cause flashover in distribution lines as the clearance in distribution lines are low. The protective measures against lightning include: first is overhead ceiling wires or earth of transmission and distribution lines. Zone of protection 45 degree on both sides with respect to vertical line plane. Second is overhead shielding mesh for outdoor substation. Zone of protections 45 degree on both sides. Third one is earthing of overhead shielding. Overhead earth wire towers or poles. Fourth one is earthing mast lightning spikes in substation and on tall buildings on towers. Zone of protection 45 degree on protection with respect to vertical line. Fifth is surge arresters, lightning arresters. Connected face to ground on transmission towers, distribution poles, substation, power stations to discharge lightning surges. And six is co-oriented spark caps like a urst at other end, connected face to ground to protect insulators and bushings. Now, what are the switching surges and how do they occur? Overvoltage produced during the opening or closing circuit breakers are called switching overvoltages. The overvoltage are due to sudden exchange of energy from series inductance in the circuit and the shunt capacitance of the circuits. Switching overvoltage or surges have a time duration range of 100 to 3000 microseconds and peak value about 2 per unit to 4 per unit. Circuit breakers opening presents a change from current carrying state to voltage withstand state and produce switching surges due to sudden transfer of energy from inductance to shunt capacitance. First is low inductive current switching like a motor switching, transformer on no load switching, etc. The vacuum circuit breaker VCB used for 3.3 kV to 33 kV systems and air blast circuit breaker ABCB used formerly for EHV AC circuits, now obsolete, have a tendency to chop current before natural current 0. Next is EHV AC transmission line switching duties. EHV AV transmission line has distributed series inductance and shunt capacitance. Opening a long transmission line and closing a long transmission line tend to produce switching overvoltage of the range above 3 to 2 per unit. Switching duties of significant switching overvoltage include opening unbalanced or unloaded lines, reclosing on charge line, opening line on short line, fault opening. Now, protective measures and preventive measures. Use circuit breaker with pre-inertiance resistors. Use of surge arrestor between phase and ground to limit switching surge. Use of surge suppressors. Re-closings or pre-closings resistors are in parallel with the main breaker contact pairs. While closing the circuit, the pre-closing resistors close first. Thereby, the switching surges on closing transmission line are reduced in magnitude. Opening resistors are in parallel with the main breaker contact pairs. While opening the circuit, the opening resistors open first, thereby the switching surges on opening transmission lines reduced in magnitudes. Surge arrestor between the phase and ground near breaker terminal on the line sides. Now, what is the size of the earth electrode? Earth electrode can be different types. Plate or electrode is usually in the form of 1 meter into 1 meter into 12 mm thick cast iron plate. These are used for low voltage installation. Pipe electrodes is usually in the form of 30 to 40 mm diameter and 2.5 m long galvanized iron pipes or solid mild steel rods. These are used in substations and power plants. Earthing pit should be filled with charcoal, common salt and soil to reduce earth resistivity. And next is typical station earthing systems and the earth electrode spike. Station earthing system has following components. First is horizontal underground earthing mesh of steel rods. Second is risers, and third one is earthing conductors. The earthing mesh is formed by welding the horizontal steel rods placed in the trenches at a depth of about 1 meter. The joints are welded. Risers are vertically rods welded to the mesh. Several vertical earthing spikes like electrodes are driven in the area, and these are connected to the earthing mesh by means of welded steel rods. Various points to be earthed are connected to the earthing mesh by means of conductors. Metallic switchgear earthing. Various panels in the switchboard are provided with the common earthing bus. The earthing bus is connected to the station earthing systems via two risers. A special earthing truck is provided for earthing the bus bars. Main equipment in station earthing system is first is earthing electrodes or spike. Next, earthing out conductor, risers, shielding wire, surge arresters, earthing switch terminal, transformer neutral, cable and heat, equipment body or frame body, and metal clad switch gear. So these are the main equipment of the station earthing systems. So this is the very most important of earthing system in substation, generating station and overhead line. If earth resistance is high, what are these actions should be taken? Clean the surface of earth electrode, mix the soil in the earthing pit with charcoal, salt and soft soil mixed together. Pour sufficient water in the earthing pit. Connect the earthing rod with the help of equipment and low resistance copper stick, and use more number of electrode and larger base. Okay. Now, small resistance buildings need simple earthing systems, while the substation, generating station, overhead lines require more. Okay. It is the only one or two electrodes. The earthing electrode is in the form of metal plate or a pipe or rod buried in the grounded with charcoal mixed in the surrounding soil. Space should be kept moist to reduce earth resistance. Okay. So the difference between the small and large installations may have the resistance up to about 2 ohms up to mega ohm. Okay. Thank you.